dear students, welcome to Power Electronics GATE and ESC classes. Myself Surendra Babu. In this session, I would like to discuss about some introduction on power electronics. Students, power electronics is very important and very interesting subject and easily scoring subject for any competitive exams point of view. And mainly for GATE point of view, very less syllabus and more weightage subject students. That's why this very important mainly for GATE exams point of view. Who are preparing, don't neglect this power electronics subject students. First we will see some introduction. According to given GATE and ESC syllabus, the total power electronics syllabus I divided into 8 chapters. One is power semiconductor devices, AC to DC converters. In this, in detail about rectifiers will be covered, that is both single phase rectifiers and 3-phase rectifiers. The next one is DC to DC converters, that is the choppers. Fourth chapter is DC to AC converters. In this, inverters will be covered. DC to AC converters are nothing but inverters. AC voltage controllers. This AC voltage controllers, this also AC to AC converters. With voltage is variable, frequency constant. In detail about this later on we will see. And the sixth chapter is cycloconverters. This also AC to AC converters with variable voltage and variable frequency. Voltage is variable and frequency. The seventh chapter is fundamentals of drive. Eighth chapter is miscellaneous. In this miscellaneous topics mainly I would like to discuss about SMPS concept, switched mode power supply concept. But point to remember students, as for GATE syllabus, these topics only it is given. But even though topics are given up to inverters only, but my suggestion is you have to prepare AC voltage controllers and cycloconverters also. Don't neglect, even though syllabus is given up to inverters, you must and should prepare AC voltage control and cycloconverter. You have some minimum knowledge students. That's why GATE point of view, these topics are important as for given syllabus. As for given syllabus, for GATE point of view, this is important students. Then all these topics are important, with respect to ESC point of view. As for GATE and ESC syllabus, I divided into 8 chapters. 1 to 6 chapters. 1 to 6 chapters is important for GATE point of view. And remaining 7th, that is 1 to 8th, chapter 8, this is important for ESC and any other PSU's point of view also it is important. Any other PSU's point of view also important students. Okay. Now we will start with some introduction with respect to power electronics. Students, we know that electrical and electronics engineering who are studying EEE or who are studied the EEE, who are completed EEE, this electrical and electronics engineering is divided into 3 parts of specializations. One is power engineering. Another one is control engineering. Third one is, here I am giving some introduction students, all of you concentrate, electronics engineering. That means who studied or who are studying the electrical and electronics engineering, they are eligible for power engineers, they are eligible for control engineers, and they are also eligible for electronics engineering. Then what the power engineering deals? It deals with generation, transmission and distribution of electrical energy. What the control engineering deals? It deals with the steady state and dynamic characteristics of a system. That is, under steady state condition, under dynamic condition, what the response of the system, that is explained by the control engineering. Electronics engineering, it deals with the solid state devices and circuits for signal processing. But in with respect to power electronics point of view, how the power device, how the electronic devices we can use at power level, okay, that is explained by the power electronics. These are the power engineering, control engineering and electronics engineering students. Now I have to give one simple definition for power electronics. But it is not the exact definition. After some time I will give the exact definition of power electronics, but here I am giving the one simple definition of power electronics. Students, just now I told all electrical and electronics engineering, EEE, is divided into three parts of specializations. One is power engineering. The next one is control engineering, that I told already. Just for understanding, I am giving the one definition, students, but this is not the exact definition of power electronics. The power electronics is nothing but a use of electronic devices. Use of electronic devices to control the power is nothing but a power electronics. Use of electronic devices to control the power is nothing but a power electronics. Students, we know that in general, electronic devices are developed at signal level, very low voltage and current levels. How these electronic devices are developed at power level? After developing the electronic devices at power level, by using those devices, how to control the power and how to convert the power. All these are explained by the power electronic technology. That is, use of electronic devices at power level and how to develop the electronic devices at power level. This is explained by the power electronic technology. That is, power electronics may be defined as the application of solid state electronics for the control and convert of electric power. That is, at power level, how we can use solid state electronic device. That is explained by the power electronics. But point to remember, friends, what are the major components of the power electronic system? Mainly it consists of one power modulator. What is the power modulator here? The power modulator is nothing but a power electronic circuits. This is one of the power electronic circuit. This power electronic circuit may be rectifier, or it may be a chopper. Based on the application, we can use different power electronic modulators, or it may be inverter, or AC voltage controller, cycloconverter. Based on the application, different power electronic modulators we can use. The output of the power modulator is given to the motor to control the motor. That speed of the motor is controlled by using the power electronic converter. Then output of the motor is given to the load to drive the load. But this output of the motor is measured by sensing unit. According to requirement, this sensing unit will send the signal to the control unit. This control unit will control the power modulator to get the required output of the motor. Like this we can control. But in detail about this, how the motor is controlled, that you will see in electric drive system only. That is in fundamentals of the electric drives only. But here the point you have to concentrate, what are the major components? Power modulator, motor, load, sensing unit, control unit and source, students. See, in this total power electronic system, the sequence of selection of various components, this is the sequence. First we have to select the load, students. Then you can select the motor. Then you can select the power modulator. Then you can select the source. This is the sequence of selection. Directly don't select the source, because based on the load only motor you select. Based on the motor only you select power modulator. For example, DC motor. The output of the power modulator must be DC. If it is a AC motor, the output of the power modulator must be AC. This is the sequence you have to select. Based on the power modulator only you have to select the source. For example, I am using rectifier, then source is AC. I am using inverter, source is DC. I am using AC voltage control, source is AC. Okay, like this you have to select. Okay. These are the major components of the power electronic system. Now, point to remember, friends, among all the technologies, the more popular technology is the power electronics. Now the question is, sir, why the power electronics is the more popular technology? If any technology is more popular, mainly depends on the following factors. It must be high efficient technology. It must be less size and less weight. It must be high reliability, less cost. Power electronics is satisfying all these factors. That's the reason why power electronics is the more popular technology, students. If any technology is more popular, it mainly satisfies the following factors. Power electronics is satisfying these factors. That's the reason why power electronics is the more popular technology. Again, question will arise. Sir, how to say that power electronics satisfying all these factors? Very simple. Students, point to remember. In total power electronic circuits, you take any power electronic circuit, chopper, inverter, AC voltage control, cycloconverter, rectifier, any power electronic circuit you can take. In all these power electronic circuits, we are using power semiconductor device as a switches. If power semiconductor devices are used as a switches, then those circuits are more efficient circuit because of in switch mode. Sir, if it is used as a switch, why it is more efficient? Simple. Just I am explaining the ideal case. You can interpret same concept for practical case. Ideal and practical is, ideally infinity means practically high. Ideally 0 means practically less. Like that you can interpret the concept, students. See, for example, let's consider if any switch. Ideally, if the switch is closed, students, what is the voltage across the switch? 0. Correct? Voltage across the switch is 0. But current is exist now. Voltage 0, current exists. What is the power loss? Ideally 0. Practically less power loss. One operation of switch is nothing but one on and one off. Na? Switch is open. If the switch is open, ideally what is the current through the switch? 0. But practically there is a leakage current. But I am telling that ideally current is 0. But it blocks the voltage. Na? Switch blocks the voltage. Device blocks the voltage. Current is 0, voltage exists. What is the power loss? 0. Ideally power loss is 0 means practically less power loss. If the practically power loss is less, high efficiency or less efficiency, this is satisfied. That's why power electronic circuits are more efficient circuit because all the power semiconductor devices are used as a switches in power electronic circuits. That's why these are the more efficient circuits. And one more observation, students. If the power losses are less, high temperature rise or less temperature rise? It's a less temperature rise. Because power only dissipated in the form of heat. Na? What I am telling that power losses are less. If the power losses are less, temperature rise is less. If the temperature rise is less, more cooling requirements or less cooling requirements. Like heat sinks, less cooling requirement. If the cooling requirements are less, more size or less size? It's a less size, less weight. This is also satisfied. No doubt at all, power electronic circuits are high reliability. Among all the devices, it can work for a long time. And if you consider some payback period, 1 year or 6 months or 2 years, 3 years, 4 years, 5 years, like that some payback period you consider, these devices also less cost. Okay. Because of these reasons only, this power electronic technology is the more popular technology. Why this technology is more popular, students? Because of the semiconductor devices. Why this technology is popular? Because of the semiconductor device. That's why the heart and soul of power electronics is the power semiconductor devices. There is no power semiconductor device, there is no concept of power electronics. The heart and soul of power electronics is power semiconductor device. Okay, this statement is very important, students. Already based on this statement, the question is framed in competitive exam, in ESC exam. Power electronic circuits are more efficient because all the power semiconductor devices are used as a switches in power electronic circuits. Used as a switches. Switches means one is saturation region. Another one is cutoff region. That's the reason why power electronic circuits are more efficient circuit because we are using in switches, used as a switches. Next. Here I am giving one or two examples, students, to make the difference between conventional devices and power electronic circuits, conventional circuits and power electronic circuits. See the example, students. This is a conventional fan regulator that you are used this in olden days, conventional fan regulator. This is the power electronic fan regulator. Internally it consists of triac, students. Nowadays we are using this type of regulators. Triac. It is a triac based AC voltage controller. Triac based AC voltage controller. See these two comparison. This is the conventional circuit, this is the power electronic circuit. Which is less size? Power electronic circuit is very less size. which is less weight, power electronic circuit is less weight. You can operate this regulator and this regulator. If you operate this regulator 24 hours, heat dissipation is negligible. Then less temperature rise, less cooling requirements. That's why this is one of the simple example for power electronic circuit, that is a fan regulator. See the difference, less size, less weight, high efficiency, all these are satisfied by the power electronic circuit. I am giving one more example. This is the RPS versus SMPS, students. RPS stands for regulated power supply that you seen in the laboratory. SMPS, that is a switched mode power supply. Switched mode, the name itself it indicates, switched mode we are using as a switches. This is power electronic power supply. This we are using in CPU, that you seen, switched mode power supply. In computer CPU, we are using this SMPS, switched mode power supply. This also rating, having some rating, this also having same rating but nearly same. For example, it is a 300 watt rating, it is a 200 watt rating, nearly same rating. But if you compare these two, this is more size, more weight and less efficiency, more losses, all these are. But what about this one? This is less size, less weight, high efficiency, all these are the advantages. Just I am giving two examples, conventional circuit and power electronic circuits. That's why whatever the factors I told, all those factors are satisfied with power electronics. That's why power electronics is the more popular technology. Now I am giving the definition of the power electronics, students. One of the important definition of the power electronics that you have to concentrate. Here I am giving exact definition. Power electronics is the technology associated with efficient conversion and control of electrical power by using power semiconductor devices. That is one of the important definition and exact definition of the power electronics that I given, students. Power electronics is the technology associated with efficient conversion and control of electrical power by using power semiconductor devices. And one more definition that I am giving. Power electronics is the art of converting electrical energy from one form to another in an efficient, clean, compact and robust manner for convenient utilization. This is also definition of the power electronics. Clear, students? But the power electronics is more popular because of which devices? Power semiconductor devices. Then what is the goal of the power electronics? If any power electronic circuit is connected between source and load, the main goal or aim of the power electronics is to control the power or to convert the power from source to load. You have to control the power or convert the power. For that purpose only, we are using a power electronic circuit between the source and the load. That is the main goal of the power electronics. Then what is the importance of the power electronics, students? To give the importance of power electronics, here I am giving some quotations. These quotations will give the importance of the power electronics nowadays and in future also. Yes, students. We now live in a truly global society in the highly automated industrial front with economic competitive of nations. Two technologies will dominate in future, nowadays and in future also. Computers and power electronics. The former providing intelligence as what to do and the latter the means to do it. That means here we are comparing the power electronics with the computer, students. You know the importance of the power electronics. That is the importance of, you know the importance of the computers. That is the importance of the power electronics. I am giving one more quotation. All these introduction, students, that you have to concentrate. Modern computers and communications and electronic systems get their lifeblood from the power electronics. You take any computer system, any communication system. Internally, we are using some electronic circuits. That is mainly power electronic circuits. Without power electronic chip, there is no working of any computer, there is no working of any communication system. That is the importance of the power electronics. And one more point you remember, students, solid state electronics was brought in the first electronic revolution, whereas power electronics was brought in the second electronic revolution in the developing of power electronic circuits. Generally starting whatever the solid state electronic devices are there, that is used only at signal level, low voltage level. But once power electronic devices are developed, those devices we are using at power level, this is the second revolution in the electronic circuits. These are the importance of the power electronic circuits. Then what is the advantages of the power electronics, students? I told already, these are the high efficiency due to low losses in power semiconductor devices, because power semiconductor devices are used as a switches. That's why power electronic circuits are the high efficiency. High reliability, because it can work for a long time. Long life and less maintenance due to the absence of any moving. This is important. All power electronic circuits are the static circuits. All power electronic circuits are static circuits. There is no any rotating parts. You take any power electronic circuit, students, there is no any rotating part, there is no any moving part. All are static circuits, because semiconductor devices are the static devices. That's why there is no moving part. Once there is no moving part, there is a less power loss. Fast dynamic response of the power electronic system as compared to electromechanical converter system. You take any other system, the response of the power electronic system is very fast. Sudden response we can get. Very fast output we can get from the power electronic converters. Small size and less weight result in less floor space. If the size and weight is less, it occupies the less space. Therefore, lower installation cost. And mass production of power semiconductors has resulted in lower cost of the converter equipment. You know that at a time, more number of semiconductor devices we have to produce. Once we can produce a more number of semiconductors at a time, the cost of the power electronic circuits are less. Okay, these are the advantages of the power electronics. But even though more advantages are there, but there is one or two disadvantages also there, students. One of the main drawback of power electronic circuits is it introduces the harmonics into the load. That is a problem. Main drawback is harmonics, students. Power electronic converter circuit tend to generate harmonics in the supply system. It generates the harmonics. See, for example, I am using any one power electronic converter. Let us assume that I am using the inverter. I am using the inverter. By using this inverter, we are controlling a three-phase induction motor. Let us assume that we are controlling a three-phase induction motor. Using this, we are controlling three-phase induction motor. Using this inverter, we can control the three-phase induction motor, but problem is it introduces the harmonics into the motor. It introduces harmonics. This is the main drawback. Along with control, it introduces, because whatever the power electronic output is there, we are not getting pure sinusoidal. We can use some filter arrangement, all these to reduce the harmonics. That is one of the main drawback. AC to DC and AC to AC converters operate at low input power factor under certain operating conditions. In order to avoid low power factor, some special measurements to be adapted. That means if you take the AC to DC converter, you take the AC to AC converter, during the operation whose input power factor is less, to improve that power factor, special techniques you have to use, which increases the, that is special measurements is required, which increases the cost also. And special techniques you have to use to improve the power factor. Power electronic control have low overload capacity. This is also important, because we know that all the semiconductor devices are more sensitive to temperature. Now, if any high currents are flowing, then there is high temperature rise, the device may be permanently damaged. That's why these are having the low overload capacity. Regeneration of power is difficult in power electronic controller system. All these are the disadvantage. I already given the advantage, students. But as compared to advantages, the disadvantages are negligible. That's why in most of the all the applications we are using the power electronics everywhere. You take the any application, students, in industrial application, in domestic application, you have to take the in aircraft application, you can take in solar system, wind system. In any applications we are using the power electronic circuits. Here I am giving some important applications of the power electronics, students, that you have to concentrate. First you will see the what are the applications in our daily life. In our daily life, we are using as a vacuum cleaners, in UPS application, uninterrupted power supply. In computers also we are using power electronic circuits. In air conditioning, ACs also we are using power electronics. In industry's point of view, what is the application, friends? In industry's point of view, in rolling mills, elevators, pumps, cement mills, construction industry, in all these we are using the power electronic circuits. That is in industrial point of view. In renewable energy sources point of view, in solar system and wind system, we are using the power electronic circuits. Okay, everywhere you take any application, daily life, industry, renewable energy, automotive and traction, utility system, defense and aerospace, everywhere there is a power electronic circuits are there. Then in defense and airspace, that is aircrafts applications, satellites and space shuttles also we are using the power electronic circuits. In automotive and traction application point of view, forklifts, subways, hybrid electric vehicles, ships, electric power steering, modern traction system, in all these we are using the power electronic circuits. In utility system, mainly in smart grids, fax and XVDC transmission, we are using the power electronic circuits, friends. Okay, that you have to consider. Okay, these are the applications of the power electronic circuits. Yes, friends, I told already, for GATE and ESC point of view, this is very important subject and easily scoring subject. Less syllabus, more weightage. Then what is the expected weightage from the power electronics point of view? Power electronics, for GATE point of view, the expected weightage is 8 marks to 10 marks we can expect, friends. 8 marks to 10 marks. Average I am giving. But up to now, the maximum marks asked from the power electronics is 12 marks is also asked. But average weightage is 8 marks to 10 marks. It is a very good weightage. Getting the 8 to 10 marks is very easy from the power electronics once you can follow our lectures. Next. For ESC point of view, what is the expected weightage, students? For engineering service exam, the expected weightage is, for engineering service exam, both objective and descriptive exam is there. For objective point of view, the expected weightage is 10 questions to 12 questions we can expect. Greater than 12 also we can expect, but average I am telling that 10 questions to 12 questions. Each question is having equal marks into 2, that is 20 marks to 24 marks we can expect objective point of view. For descriptive point of view, the expected weightage is 35 marks to 50 marks we can expect, friends. Average I am telling that. This is the expected weightage for ESC point of view. For any other PSUs point of view, students, any PSUs, either central government jobs or state government jobs, the expected weightage is out of 100 marks, in any PSUs point of view. You take central government jobs, that is you have to take ISRO exam, DRDO exam, bark exam, or any state government's electricity jobs point of view. The expected weightage is out of 100 marks, 8% to 10% of marks we can expect. 10%. That is out of 100 marks. The power electronics, from power electronics we can expect 8 marks to 10 marks. Minimum weightage we can expect different competitive PSUs point of view, students. Okay, this is expected weightage from the power electronics. Then finally I have to give what are the reference books in power electronics. Here so many books are there, students, but my point of view, the first preference is given to the power electronics by P.S. Bimra. Except 1 or 2 topics, some mistakes are there, except that, but it's a very good book for both theory and numericals. To practice the questions from standard textbooks means you have to practice the questions from power electronics by P.S. Bimra. The next one is power electronics by Ned Mohan. This also important book. You have to practice the questions from power electronics by Ned Mohan. This also important for both theory and numericals. For both theory, mainly you have to concentrate theory. Power electronics by Cyril W. Lander. This is important only for numericals that you have to practice. There is so many models of questions are there that you have to concentrate. And power electronics by Power electronic circuits design and application by Muhammad A. Rashid, or maybe H. Rashid, okay, that you have to take, and this is also important book. Power electronic device drivers and application by B.W. Williams. This book is also important, students. Mainly you have to practice the numericals from this one. More number of numericals are given that you have to practice. And power electronics by M.D. Singh and Kanchandani. Power electronics R.S. Ramshaw and P.C. Sen. Like this, so many books are there. But my point of view, students, what you can do with respect to power electronics, whatever the lectures we are giving and what are the models of questions I am solving in the class itself, that whatever the concept that concept you have to follow, that models of questions you have to practice. After this, solve the gate questions, solve the ESC question. If time is there, then you go for the solving of the questions in some standard textbook. Mainly 3 books. One is P.S. Bimra, another one is Ned Mohan, Cyril W. Lander, and other one is B.W. Williams. From that books you have to collect the numericals, that only you can solve, students. That practice is enough for the power electronics point of view. Yes, friends, this is about some introduction with respect to power electronic subject. In the next session, we will start with the first topic in power electronics is types of switches, that is also called types of devices in a power electronic subject. That is a first topic, that is a very important topic, types of devices or types of switches. Thank you.